Hey everyone, today we are going to do A2 level organic chemistry, or we can also use this video for the imat organic chemistry. So let's start with addins first. Addins are hydrocarbons, meaning they contain hydrogen and carbons only. And addins are based on the concept of benzene, which states that in an addene, there are 6 carbon atoms and 6 hydrogen atoms. And remember, benzene is unsaturated and it is very stable. So what is a benzene? A benzene is a compound that consists of 6 carbon atoms arranged in a regular hexagon. So the shape that you usually see for a benzene would look something like this, with a circle at the center. So the bonds of the carbon to carbon, or the carbon to carbon bonds, are sigma. All of these carbon to carbon bonds are sigma, and they are sp2 hybridized. The bond angle for these carbon to carbon bonds in the benzene is 120 degrees, and the shape is trigonal planar. So all of these carbons can only make 3 bonds instead of 4. So remember, in a benzene ring, you can only make 3 bonds instead of your normal 4 carbon bonds. And the remaining p orbital is non-hybridized and has an unpaired electron. So the 6 paired p orbital, one in each carbon, are parallel to each other and perpendicular to the plane of the ring. Each p orbital will overlap equally with both its neighbor, forming a delocalized six center molecular pi orbital. So this ring that you see right here has 6 electrons present in that ring, and each carbon will give 1 electron to this ring, and this will be called a delocalized ring. So you have huge concentration of electrons present in this ring. Moving on, the 6-centered delocalized pi bond causes all carbon-to-carbon bond lengths to be equal, creating a planar regular hexagonal shape. This also prevents the benzene ring from undergoing any addition reactions that alkenes usually show. So only substitution reactions will happen with benzene rings. And remember that benzene is more stable than an alkene. It is less reactive and uses stronger conditions for reactions compared to alkenes. Moving on, benzene C6H6. Remember, this is the formula for a benzene ring. Benzene are non-polar. They have temporary dipole-dipole attraction. They are insoluble in water, meaning they don't dissolve in water. Why is that? Because they are non-polar. Remember, water molecules are polar, so they will always form bonds with polar atoms. And benzene ring also undergoes addition reactions, and it does not undergo addition reactions. Moving on, let's start with the reactions involved with benzene. First is bromination. Bromination is when a bromine atom attaches to the benzene ring, and you form this benzene ring with a bromine atom. The reagents for this is FeBr3, or you could use AlBr3 plus bromine atoms. And similarly, chlorination is the same as bromination. And instead of using FeBr3, you'll use FeCl3 or AlCl3. And the same conditions, so you'll add chlorine atoms to chlorination. So AlCl3 or FeCl3 are acting as catalysts. That means at the end of the reaction, you will have AlCl3 present. So one of the products would be AlCl3. So after chlorination and bromination comes alkylation. Alkylation is when you have an R group, or basically CH3, C H2 groups that attach to the benzene ring. And the reagent for this is again AlCl3 plus the alkyl group attached to a chlorine atom. So the chlorine atom attached to the R group will attack the benzene ring, and the chlorine would react with hydrogen and form HCl, and the R group attaches to the benzene ring. So moving on, acylation is when you have this carbon attached to a double bonded to an O with an R group. And acylation is when this compound, this carbon atom, can have a chlorine, a bromine, or any other atom. When this atom will bind to a benzene, that's when you have acylation. So the reagent for this is the acyl group, the C double bonded to O, R group must be attached to a chlorine atom. And plus you have the catalyst, which is AlCl3. And you will also heat all of these. So the product that you will get is this acyl group attached to the benzene. So moving on with the reactions, you can also have a carbon double bonded to an oxygen with a CH3 group. And the condition for acylation again is this carbon must be attached to a chlorine atom plus AlCl3 plus heat. So when all of this reacts with a benzene ring, what you'll get is the acyl compound would attach to the benzene, and the chlorine is given off. The chlorine deattaches from the acyl group, and you'll get this ketone right here. So moving on with benzene reactions, then comes nitration. Nitration is when you get a nitrogen dioxide group onto the benzene. The reagents and conditions for this is conc H2SO4 plus conc HNO3, and you heat at 50 degrees. So the electrophile that is present in this reaction is the NO2 plus group. So basically, the H2SO4 would react with HNO3, and what you get is HSO4 minus ions, H3O plus ions, and the NO2 plus ion. This right here is acting as the electrophile, and then this electrophile attacks the benzene. So moving on with hydrogenation. Hydrogenation is when the benzene ring or the benzene reacts with hydrogen in the presence of nickel catalyst, and you will heat at 200 degrees Celsius. The conditions are same as the alkene reaction, where hydrogen would react with alkenes in the presence of nickel catalyst, and what you'd get is alkanes. So what happens in hydrogenation in benzene? In benzene, when hydrogen reacts with benzene, the benzene ring would be gone, and you'll have all single bonds present. So the number of hydrogens would double. So when you had C6H6 at the start, now you'll have C6H12. From a benzene, you are going to a cyclohexane. So you can see that the hydrogens would double. Each carbon would gain one extra hydrogen. So moving on with oxidation of a methyl benzene. When you have a methyl benzene, basically a methyl group attached to the benzene, if you react it with KMnO4 and you heat it, this methyl benzene would become a carboxylic acid group. So what you'll have is a benzoic acid. And no matter how big the alkyl chain is, it will still make it will still make CO2H with one carbon. So for example, if you had a CH2 CH3 group on the benzene ring, so for example like this, then if you oxidize this, what you'll get is the benzene as it is, but this CH2 CH3 group, this alkyl group, would become a carboxylic acid group. So you'll have carboxylic acid. So no matter how many carbons you have on the chain, it will always become one carboxylic acid group. So also remember that if you have a methyl group on a benzene, that is called a 2,4 directing group, meaning if this methyl benzene would react with, if this methyl benzene would react with chlorine, so for example, it underwent chlorination, then the chlorine atom would be placed on the 2 and the 4th position of the carbon atom. And you can always start the numbering from the carbon that has the CH3 group. So this is the first carbon atom. The second carbon atom is this right here. And remember, methyl benzenes are 2,4 directing. So the chlorine would be attached to the carbon number 2, or it can be attached to carbon number 4 as well. And it can also be attached to carbon number 6. So 2, 4, and 6 are the carbon positions that you can attach the chlorine atom if you have a methyl benzene. But if you have a nitrobenzene, if you have a benzene group, if you have a benzene that has a nitrogen dioxide attached, then this compound right here is 3,5 directing. That means if chlorine was to be added to this benzene group, then the chlorine would attach to carbon number 3, so here, or it could be attached to carbon number 5 right here. So moving on, phenols would react with nitric acid. This is a very important reaction. What is a phenol? A phenol is basically a benzene that has an OH group attached to it. So phenols, right, is stronger than alcohols. The CO bond is stronger in phenol than in alcohols. So a phenol would react with sodium, and what you'll get is this hydrogen getting replaced by the sodium atom. And you'll also make half a mole of hydrogen gas. Similarly, if you want to get nitrogen dioxide on a phenol, you'll react the phenol with dilute hydrogen. You'll react it, this phenol with HNO3, and it must be dilute. And moving on, bromination of phenols is when you take bromine, but this time you don't need a catalyst, because phenols, remember, phenols are stronger than alcohols. So phenols are stronger, they react much faster than compared to benzene. So you don't need any catalyst, you don't need AlBr3 or FeBr3 when you're reacting a bromine with a phenol. So what you'll get is this benzene ring right here would be gone, and bromine would be attached to either carbon number 2, carbon number 4, or carbon number 6. So this was phenols and benzene rings. Now moving on to carboxylic acids. Remember that carboxylic acid is a stronger acid compared to a phenol, but it's a weaker acid compared to hydrochloric acid. So the strongest acid is a hydrochloric acid, then comes carboxylic acids, then comes phenols, then comes water, and finally comes alcohols. Remember, alcohol is the weakest acid. HCl is the strongest acid. And if you were to react carboxylic acid, phenols, and alcohols with sodium hydroxide, and sodium carbonate, you'll get these observations right here. So this is a good way to figure out if something, how acidic is something. So remember that carboxylic group, the carboxylic acids, would react with sodium to make hydrogen gas. It would neutralize sodium hydroxide because it's acidic, and it will produce carbon dioxide gas when reacted with sodium carbonate. Similarly, phenols can react with sodium to make hydrogen gas. It can also neutralize sodium hydroxide because it's acidic, but it has no reaction when you react phenols with sodium carbonate because it is not a very strong acid. So alcohols are the weakest acid. Alcohol would react with sodium to make hydrogen gas, but it cannot neutralize sodium hydroxide because it's a very weak acid. And it can also not react with sodium carbonate. So you'll have no reactions. Let's move on to amines now. Remember that ammonia is nitrogen with 3 hydrogen atoms, and the nitrogen has a lone pair. What is a primary amine? A primary amine is an amine is a primary amine is a nitrogen that has 2 hydrogens, 1 lone pair, but instead of the third hydrogen from the ammonia, you'll replace this with an R group. The R group can be anything, CH3, CH2, or CH2CH3. It can be any kind of group. A secondary amine is when you have 2 R groups instead of 1. So 2 R groups. And similarly, a tertiary amine is when you have 3 R groups present on the nitrogen. And remember, amines are bases. All of these amines are bases. And also ammonia is a base. So it can act as nucleophiles. Amines can act as nucleophiles as well. So what are the nitrogen containing groups? You have amines because they have a nitrogen. You have a nitrile. A nitrile is basically nitrogen that has a triple bond with a carbon atom. And you have amides. Amides are carbon with double bond oxygen and a nitrogen. So carbon, which is double bonded to an oxygen and nitrogen, that is called an amide group. So you can see this right here is the amide group. And finally, the last nitrogen containing compound is nitrobenzene. A nitrobenzene is basically a benzene ring, a benzene that has nitrogen dioxide. So moving on, what are the reactions with that make amines? So first of all, reduction of nitrile is when you react lithium LiAl4 with dry ether and you heat it. So what happens is this nitrile, a nitrile, remember, is a carbon triple bonded to a nitrogen group. So this nitrile would break, the triple bond would simply break, and what you'll get is hydrogens on the nitrogen group, a nitrogen atom. And you'll also get hydrogens on the carbon atom as well. So 2 hydrogens right here and 2 hydrogens on the nitrogen group. The second type of reaction with nitrogen containing groups is halogenoalkane nucleophilic substitution. It's when halogen, right? Halogen with an R group reacts with ammonia. What happens is this ammonia would substitute with the halogen. So, for example, if you had ClCH3, that if it reacted with ammonia, what you'll get is when this reaction happens, you'll get NH2 CH3 plus HCl. So the hydrogen, one of the hydrogens from the ammonia would react with the chlorine atom and make HCl. And the NH2, the remaining NH2, would substitute with the chlorine atom. So this was the second type of reaction involving nitrogen-containing compounds. The third type of reaction is when you convert a halogen to a nitrile and then a nitrile to an amine group. So let's say that I have this halogen containing compound CH3CH2Cl. I can react this group, this compound, with ethanol in NaCN. Ethanol in NaCN. And if you heat under reflux, what you'll get is this chlorine group being replaced with a cyanide atom, Cn. So what you get is a nitrile group. And this nitrile, right, this Cn group can become an amine group if you react LiAl4 in dry ether and you heat under reflux. So what happens is this Cn group, right? This Cn group becomes a NH2 group. And you can also directly convert this halogen containing compound into an amine when you react NH3 in ethanol. So if this halogen containing compound reacted with NH3 in ethanol and you heat under reflux, you can directly make an amine, meaning this halogen right here, this chlorine atom, gets replaced by an NH2 group. So remember, halogen containing compounds can become nitriles and then nitriles can become amines. Nitrile is, remember, it's a carbon having triple bond with nitrogen. This nitrile can be converted to an amine. And similarly, you can directly go from a halogen to an amine if you react NH3 in ethanol with the halogen containing compound and you heat under reflux. And remember the two-step reaction when you convert this halogen containing compound to a nitrile and then to an amine, this reaction adds an extra carbon to the group because you are adding a CN group instead of a halogen group. So there is extra carbon when you undergo the two-step reaction to make amine. And finally, the fourth reaction containing a nitrogen containing compound is the reduction of an amide. Remember, amide is carbon double bonded to oxygen, which has a nitrogen attached. So an amide can get reduced to an amine with the addition of 4 hydrogen atoms. And this can be done by any reducing agent. So LiAl4 in dry ether. This, when you reacted an amide with this reducing agent, this can reduce an amide into an amide. And remember, reduction is when you add hydrogens. Oxidation is when you lose hydrogens. So reduction, a good reducing agent is lithium aluminum hydride or LiAl4 in dry ether. This is a very good reducing agent. And an oxidizing agent is KMNO4. This is a very popular oxidizing agent. So yeah, these were the reactions with nitrogen containing compounds. So let's move on to phenyl amines. A phenyl amine is this this benzene that is attached to an NH2. So how does this happen? If you take a nitrobenzene, basically a benzene attached to a nitrogen dioxide, and you react it with SN plus conc HCl, and you heat this reaction, this nitrogen dioxide can become NH2, or a nitrobenzene can become a phenylamine. Phenylamines, remember, it's basically an amine group attached to a benzene. So remember, amines act as bases. Amines can react with acids and make salt plus water. So remember that the strongest type of amine is an alkyl amine, and the weakest type of amine is a phenylamine. So uh, if you have alkyl amine, ammonia, and phenylamine, then the strongest type of amine would be an alkyl amine, and then comes ammonia, and then finally the weakest type of base is a phenylamine. Uh, Moving on with the reactions involved with phenylamine, if you react phenylamines with bromine, then you'll get bromines on the 2, 4, and 6 positions. So remember, a phenylamine can react with bromine, and you'll get bromines on the 2, 4, and 6 positions. Remember, this is the 4th position, not this. Yeah. And this is the 6th position, not this. Yeah. So the point was, you make a phenylamine will get bromines when reacted with bromine, and this reaction has a white precipitate that is being made at the end of the reaction. You'll also get hydrogen bromide as well. So yeah, and phenylamines, remember, can react with dilute HCl and NaNO2 at 5 degrees Celsius to make something called a disonium salt. Disonium salt is basically a benzene that has a nitrogen, two nitrogens, and a chlorine attached. This disonium salt can react with water and make a phenol. So this disonium salt can become a phenol. A phenol, remember, is a benzene with an OH group. This can happen when you have water present. And yeah, so a disonium salt, remember, can react with phenols. If this disonium salt reacts with a phenol, what you get is an azo dye. So if I have a if I have a disonium salt, it reacts with phenols in alkaline solution. Remember, the phenols must be in alkaline solution, so it can be dissolved in NaOH. The phenol can be dissolved in NaOH, and what you get when these two react, you get a disonium salt, which looks like this. And remember that above 10 degrees, the disonium salt will decompose to form phenol. So reaction must take place at 10 degrees or less than 10 degrees Celsius. So moving on, there is a reaction called amide hydrolysis. When amides react with water, what you get is a carboxylic acid group plus the amine group. So basically, the amide, right, the carbon double bonded to oxygen that has the amine group, which is this right here. This is the amide group. When this reacts with dilute acid or alkali, plus you have water, so it must be dilute so that you have water. If this amide reacts with acid or alkali, which are both either, it must be dilute, what you get is this carbon nitrogen bond would simply break off, and this carbon double bonded to O gains an hydroxyl group, so an OH group, and this nitrogen gains one hydrogens. So this nitrogen will gain one hydrogen, and it would become an amine. So amides can also be reduced to amines like we did before. So if you have an amide, for example, C double bonded to NO with a NH2 group, this is an amide. And if this gets reduced by lithium aluminum hydride, what you'll get is the double bond O with carbon breaks, and you get carbon with two hydrogen groups. So the carbon gains two hydrogens and the oxygen gets out. Because remember, reduction is loss of oxygen. And it's also the gain of hydrogens. So yeah. Finally, what is an acyl chloride? An acyl chloride is a carbon double bonded to an O with a chlorine atom. This right here is an acyl chloride group. How are acyl chlorides formed? When you have a carboxylic acid group that reacts with PCl5, you will get a acyl chloride. So the OH of the carboxylic acid group gets replaced by a chlorine. And the byproducts are HCl and POCl3. So remember this reaction, a carboxylic acid group reacts with PCl5, and you'll get an acyl chloride, you'll get HCl, and you'll also get POCl3. And an observation for this reaction is you'll get white fumes because HCl is white fumes. And similarly, if this acyl chloride was to hydrolyze, meaning you add water to this, then this acyl chloride can be converted back into a carboxylic acid group. So moving on with hydrolysis with alkylase. So if you have an acyl chloride that reacts with alkali, let's say NaOH, what you'll get is, this must be dilute. What you'll get is a carboxylic acid plus the chloride ion or HCl. So there is acyl chlorides that would react with ammonia as well. So if you have an acyl chloride that reacts with ammonia, what you will get is this chlorine atom gets substituted with the NH2 group. And the NH3, right, the hydrogen from the NH3, one hydrogen from this would combine with chlorine and make HCl. So remember, acyl chlorides react with ammonia, and the product you get is amides plus HCl. So for example, if I had this acyl chloride, C double bonded to O with a chlorine, C double bonded to O with a chlorine, and a CH2 CH3 group. CH3 group. If this was to react with ammonia, what you will get is the chlorine right here, right? The chlorine would, if this reacted with ammonia, the chlorine would simply get replaced by an NH2 group. And you'll also make HCl as one of the products. So remember that acyl chlorides can also react with amines. So if you have an acyl chloride that reacted with an amine, so for example, you have this acyl chloride. Remember this right here, C double bond OCl is the acyl chloride group. If this was to react with an amine, so this is an amine. This is a secondary amine because it has two hydrogens. Sorry, it's a primary amine because it has one R group. So if this amine was to react with acyl chloride, what you'll get is this hydrogen would combine with chlorine and make HCl. And the remaining of this product, the remaining of this amine would attach to the acyl chloride. So the what you'll get is this product right here. So the remaining amine group will attach to the C double bond O, and you'll get an amide as well as the HCl. So yeah, acyl chlorides plus amines give you amides plus HCl. So this was basically all of A level, A2 level organic. And this was also part of imat organic. So yeah, see you in the next video. Bye.